as you notice, I see the highest exponent is 2, right? But it has something funky monkey going on here. It's not just a y squared, it's like a y minus 3 squared, and a y minus 3 here. So when we see this thing, I see something b squared minus 5 times something plus 4. So this something, what I'm going to do, instead of like getting rid of the parentheses and multiplying it all out, all this stuff, the shortcut is that I'm going to force this to look like a quadratic. So what I mean when I want to force this to look like a quadratic, so here I'm going to make it look like a quadratic. Because if it was a quadratic, we can solve it now. So Halloween is almost coming up. Anyone do anything for Halloween? You guys still dress up? Yes. Yeah? Halloween's on Tuesday. It is. Okay. Come dress up. No extra points. So maybe get candy or something. So make it look like a quadratic. So we're going to put on a costume for this quadratic equation to make it look like something we want it to look like. So whatever you want to be for Halloween, right? Dress up, Wonder Woman, whatever, Superman, whatever. I want this to look like a quadratic. So this is where we use U substitution. And this is a really powerful tool, because if you get to calculus, we use U substitutions a lot, right, Andrew? Andrew is nodding his head. U substitution. You substitute, I call U for ugly. You substitute the ugly part for something looking nice. So I'm going to substitute this here. I'm going to make the y minus 3, I'm going to make that a u. I'm going to call that a u, and then that u is going to be squared, minus a 5, and then the y minus 3, I'm going to call that a u, and then plus 4 is equal to 0. So I basically created the y minus 3 here, and I made that a u. And then since that's u, this is u being squared. Right? So this whole thing becomes a u squared. So now I have a u squared minus 5u plus 4. So to go from here to here, I need to identify what the costume is. What is the costume? And you have to write this down. I taught my earlier classes and I kept forgetting to write this step down and kind of bit them in the back later. So here we need to so the word let is very important. Let this equal to that. Let u equal to this costume. What did it take over? Y minus 3. Let y equal to u, y minus 3. Very, very important, right? To identify what the costume is. So, and I need to verify, if this is u, then if I square this, if I square u squared, I should get a y minus 3 squared. And there it is, right? So it needs to be consistent from here to here. Now that I have that, what is this now? A starts with a Q, quadratic. Now it's a quadratic. Happy face. We know how to solve quadratics now, right? So when you use U substitution, make sure you put let U equal to blank, whatever that is, because you're going to go back to that. Now that you have a quadratic, now solve the quadratic with U in it. So now, can we solve this? We sure can. When we solve this, what do we get? U minus 1 times U minus 4. Great. We're getting a lot faster with factoring, right? After we factor, what property do we use? I'm sorry? What property do I use after I factor? The ZPP, yeah, you know me. So here, set each factor equal to 0. The zero product property. So therefore, U is equal to 1 and 4. Am I done? No. No, why not? What am I supposed to, what's this problem? What am I supposed to solve for? Y, right? Because I said so. So we need to solve for y, right? So this is just a temporary costume, just to make it look easy. This is a costume, just to say, okay, now I know how to solve for u. But what I really want to solve for is for y. So now, let's take off the costume and look back at what we're trying to do. So what we're trying to do is I'm going to plug back the u is equal to 1 back into the costume to find out what the real person is, right? I'm going to plug 1 back into this equation to find out what y is. So you plug 1 in. So let me write this down. Now solve the quadratic with u. The next step is what we call back substitution. Now use back substitution, meaning you go back and you substitute it in. Now use back substitution to solve for your variable. Right? So it's kind of a cool trick. Yes, Daryl.
I kind of got a different answer, but on the answer sheet it has 7 and 4 as the.
You're absolutely right, because this is u, right? And we want to solve for y.
Oh,
yeah. Right. So way to check me. So here we want to plug this back in. When we plug it back in, the 1 back into here, I have u is equal to y minus 3. So we're saying u is equal to 1, right? So I'm going to plug 1 in for u. So 1 is equal to y minus 3. And now what do I do? How do I solve for y? Add 3 to the other side. So y is equal to what? 4. Is this what it had, 0? 4?
Yeah.
Yep. So y is equal to 4. But notice there's another u. U is equal to 4. So now I'm going to plug the 4 in for u. So I have 4 is equal to y minus 3. So what do I get when I solve for y?
7.
Y is equal to 7. Was that right, Daryl? In the back? Dun, dun, dun. Any questions on this? Yes?
I did it a different way where I distributed the squared with y minus 3, and then I just distributed 5 with y minus 3, and I just put it all together, so it ended up being a quadratic formula, and I solved it from there, and I got the same thing.
Right. So Chris did it another way where he got rid of the squares and he just multiplied the whole shebang through, and it got into quadratic form. That's totally fine as well. However, in the next few problems, you're not going to be able to do that. So yes, so this problem, you could have done it that way, or you could do it the u substitution way. So let's try with another problem, because you probably couldn't do that with the other problems, right?
Yeah.
So let's try it with another.